Right, people, let's do some graph practice here. We got a test coming up. Let's see how you do on this. All right. After 10 hours, how far has the object traveled? You can pause the video. Okay, let's see what the answer is here. Let's see how to do this. We go to 10 hours, and we see that that distance is right between 8 and 6, 7 kilometers. That's how far it's gone in 10 hours. Because see, this is a distance over time graph. That's the first thing you need to do is realize their parameters, right? What is the average speed of the object over 14 hours? So again, I'm going to let you pause that. Take a nice look at it on your computer. Okay, let's answer it. What is the average speed? Okay, so 14, boom. 14 is this E right here, okay? So it's gone, it's gone 12 kilometers in 14 hours. Velocity is equal to 12 kilometers in 14 hours. 12 divided by 14. Boom. 0.86 kilometers per hour. All righty. Give 2 points on the graph where the object is stopped. Okay, I'll let you take a look at that. 2 points on the graph where the object is stopped. All right. It's not going any greater distance between B and C, so it's stopped right here. And it's also stopped right here between D and E. Okay, excellent. Let's keep rolling. Between what two letters does the object have the highest velocity? I'll let you think about that for a second. Between what two letters? All right, the answer is going to be right here between C and D. Here's letter C, here's letter D. This is the steepest part. So between C and D, because it's the steepest. Does that make sense? All right, boom. Now this graph's different. This graph is velocity over time. Velocity over time, all right? After 10 seconds, how far has the object traveled? I'll let you pause this and take a look at it, solve it at home. All right, 10 seconds. Okay, so we're going to be right here. This is 10 seconds. Now, the area under the line on the velocity over time graph is equal to the distance traveled. So if we pull this point down here and we come down here from B, we can make a triangle right here and a rectangle right here, right? The triangle is 4 by 10, so 1/2, 4 times 10, so that's going to give 20 meters for this area, all right? 20 meters. And then for this area, it goes from 4 to 10, so that's 6 by 10. So 6 times 10, that's a square, 60 meters. 80 meters total is how far it's traveled in 10 seconds. Things moving pretty quick, isn't it? 8 meters per second, I guess. What's the average speed of the object over 20 seconds? Okay, that is a hard one, and I'm going to let you think about that one. What is the average speed of the object over 20 seconds? So here's 20 seconds right here. What's the average speed, the average velocity? Okay, now here's how you can do that. Velocity is equal to distance divided by time. So we can just see how far it's gone in 20 seconds. So we can add this. This is 4 by 4. See this triangle here? We can add the area of this triangle here, which is, like I said, 4 wide by 4 tall. So 1/2, 4 times 4. In other words, that's 8 meters. So we've got 8 meters here in this triangle. We have 80 meters so far for both of these triangles, right? And then let's add how far it's gone in this triangle right here. It goes from 10 to 13. So this one is 3 by 10. So the area of that will be 15. So 80 plus 15 plus 8 is the distance. It went 80 plus 15 plus 8. So that is what, 103? Went 103 meters in 20 seconds. So the average velocity was a little greater than 5 meters per second. 103 divided by 20 equals 5.15 meters per second. All right, looking good. Give 2 points on the graph where the object is accelerating. Give 2 points on the graph where the object is accelerating. So we're going to name these points here. I'm going to say, we're just going to do it with letters. How about this? It's accelerating from A to B. That's the point it's accelerating. Because look, the velocity is increasing. There's no acceleration here. This is decelerating, so technically that's a type of acceleration between C and D. E and F is an increase in velocity again, so that's accelerating. And there's no acceleration where the lines are flat. So anytime you have a steepness, there's an acceleration because you're changing the velocity. Last, number 8, between what 2 letters does the object have the highest velocity? All right, I'll let you think about that. Between what 2 letters does it have the highest velocity? And duh, between B and C, it's going 10 meters per second up there. All right, thanks for playing.